Assalamu alaikum, good evening, and today we are going to see the next lecture, which is chapter 27, and it's about circuits. In circuits, we will learn about single loop circuit, we will learn about the electromotive force epsilon, and then we'll see about the power dissipation through a circuit, and finally we'll solve some few questions. A single loop circuit. In a single loop circuit, to produce a steady flow of charge, we need to pump a charge. For that, we need a device which is called an EMF device, electromotive device, and the device is said to produce an EMF epsilon. So this symbol is called epsilon. Epsilon means electromotive force or EMF. EMF means nothing but it is a battery. A EMF device have a positive terminal and a negative terminal. Always the flow of electrons will be from the positive to the negative terminal, or the current flow from the positive to the negative terminal. A small circle with an arrow which denotes a symbol of an EMF device. How to calculate a EMF of a device? Epsilon is equal to work done per unit charge, or dW divided by dQ, or we can call it as a W divided by Q. The ideal DMF device is the one that lacks any internal resistance. The potential difference between its terminal is equal to the EMF, and the real EMF device has a internal resistance which have a potential difference between its terminal is equal to the EMF only if there is no current flowing through it. Therefore, work per unit charge is called the epsilon, or the electromotive force of a circuit. Now, how can I calculate the current passing through a single loop circuit? The current, we know from the Ohm's law, V is equal to I multiplied by R. Here, V means the voltage or the electromotive force epsilon. So through that, we can easily calculate I is equal to epsilon divided by R. Epsilon divided by R. Here epsilon is V. This is called the energy method. And another one is the potential method. The potential method, epsilon minus IR is equal to 0. And the energy method, energy dissipation method, which is I is equal to epsilon divided by R. So it's very simple. There are some formulas or rules are there: loop rule, resistance rule, and the EMF rule. Loop rule, the algebraic sum of the changes in the potential encountered is equal to 0. The resistance rule, for a move through a resistance in the direction of the current is minus IR, in the opposite direction is plus IR. And the EMF rule, the move through an ideal EMF device in the direction of the arrow is plus epsilon, and the opposite is minus epsilon. Based on these 3 points, we will solve the questions. Now, internal resistance. If you take any circuit, it has an internal. This is called the external resistance, and this one is the internal resistance due to the battery or due to the EMF device. So, therefore, the current I is equal to epsilon divided by R plus R. Here, epsilon is V. Here, R is the external resistance, and the small r is the internal resistance of the circuit. Okay. The resistance in series, it's same as that of the capacitance topic. The series resistance means if more than one resistors are connected in series, therefore the total resistance R equivalent is equal to R1 plus R2 plus R3. So for a parallel circuit, 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That we have already studied in the capacitance, the series combination on the parallel combination. We can easily calculate the total equivalent resistance of the circuit. And the potential difference. How to calculate the potential difference? Potential difference V is equal to epsilon minus of IR. Epsilon is V and minus IR. I is equal to IR is voltage is equal to resistance multiplied by the resistance multiplied by the current. The same formula. The power dissipated P EMF is equal to I into epsilon that we have already seen at P is equal to V is equal to IR, or P is equal to I into epsilon. Therefore, the net power P is equal to IV. Therefore, when we substitute the value, PR is equal to energy transferred as a thermal energy. That means the energy dissipation rate, internal energy dissipation rate, PR is equal to I square multiplied by R. This is another formula that we have to remember: energy dissipation rate or the power dissipation rate through a substance, through the resistor or through the circuit. PR is equal to I square multiplied by R. multi-loop, we don't need to consider, we don't need to study about the multi-loop circuit. We have to look into one more topic, which is the RC circuit. Yeah, the ammeter and voltmeter. Ammeter and voltmeter are the devices which are used to measure the current and voltage. The ammeter is the device which is used to measure the current, and the voltmeter is the device which is used to measure the voltage. Now in the laboratory, we have used the multimeter, or we can call it as DVM, digital voltmeter, or many things can be operated in one single device. We can measure the current, we can measure the resistance, we can measure the voltage, so many different things we can measure it. RC circuit, RC means resistance capacitance circuit. In the RC circuit, to charge a capacitor, the capacitor of a capacitance C in the figure is initially charged. To charge it, we close the switch S on point A. If you close, then only it gets connected. If you open, then it will not charge. So this completes an RC circuit, and consisting of a capacitor, ideal battery EMF, and resistance R. Therefore, the charge on a capacitor increases according to Q is equal to C epsilon 1 minus e power minus t divided by RC. So this is the formula to calculate the charge of a capacitor, in which Q0 is equal to C into epsilon. That also there. So please listen, please learn these two formula. The product RC is called the capacitive time constant, which is represented by the symbol tau. Capacitive times constant. Therefore, tau is equal to R multiplied by C, which is called the capacitive time constant of a circuit. So these are some of the basic information we have to study. With this idea, we are going to solve a few questions. Let me go directly into the for discharging a capacitor, we have a formula Q is equal to Q0 into e power minus t divided by RC. So if you look at the charging a capacitor, Q is equal to C epsilon 1 minus e power minus t divided by RC, and when it is a discharging happens, which will be Q is equal to Q0 into e power minus t divided by RC. Okay, these are the two formulas, remember. That's a summary. We learned about EMF, electromotive force, which is work per unit charge, which is epsilon equal to dw by dq, and the single loop circuit current I is equal to epsilon divided by R plus R, the power P is equal to IV, the energy dissipation, thermal energy dissipation rate PR equal to I square R, the EMF rate PMF is equal to I epsilon, series resistance, total equivalent resistance equal to R1 plus R2 plus R3. For a parallel, 1 by R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3. For charging a capacitor, Q is equal to C epsilon 1 minus e power minus t to the RC. So based on this idea, we will try to solve these three questions. These are the three problems which is based on the devised set of questions. Question number 15, 52 and 63. First question is 15. Let me read the question first. What multiple of the time constant tau gives the time taken by an initially uncharged capacitor in an RC circuit to be charged to 99% of its final charge? So initially it is uncharged, finally it is charged for 99%. It is an RC circuit. They are asking, what is the time constant tau? We have to give the answer of for time in terms of tau. That is the question. Calculate t value in terms of tau value. So we have given 99% charge have to be put. So we know the formula for it. The charge on a capacitive plate capacitor during charging is given by Q is equal to CE into 1 minus e power minus t divided by tau. Here it is E means epsilon. It is given E, in some book they give E, actually it is epsilon, electromotive force. Now the equilibrium charge is given by Q0 is equal to C epsilon. This is a standard formula, C into epsilon. Now when we consider this Q value, which is 99% of initial charge, or maybe the final charge, yes, which is final charge Q is equal to 99% of initial charge. The 99% is converted into ordinary number, which is 0.99. Now substitute the value of Q over here in the first equation. What we will get? Q is equal to 0.99 Q0, Q0 equal to CE, which is equal to C epsilon into 1 minus e power minus t divided by tau. Cancel the common term, we will get e power minus t divided by tau is equal to 0.01. Taking the natural logarithm on both sides, what will get? Minus t divided by. Why we have to take the natural logarithm? Because here it is an exponential form. I want to remove the take out or cancel the exponential form, take natural logarithm or ln. use your calculator directly, you can do that. Minus t divided by tau e is equal to, therefore this will become log, this e will come to the other side, log e into 0.01. When you try to calculate the value of log e 0.01, you'll get minus 4.61. Cancel the negative value on both sides, therefore t is equal to 4.61 tau. Now this is the answer. This is the time taken by this charger in terms of tau. T is equal to 4.61 tau value. So we have calculated the time in terms of tau. That's the first question. And the second question is, in the figure, what value must R have if the current in the circuit is to be 1.5 milliampere? Take epsilon 1 is given, epsilon 2 is given, and small r1, r2 is given. What is the rate at which the thermal energy appears? Thermal energy, we know the formula for thermal energy dissipation. How to calculate the R value? Now we have to consider the Kirchhoff's loop. This is a question, it is written again. Using Kirchhoff's loop rule, KLR rule, that's a single loop rule. The current will flow through one particular direction, either this direction or this direction. You can take any one of the direction. In our case, we have taken the reverse direction. Why? Because epsilon 2 is the higher value, 3 volt. So that's why I have taken epsilon 2 is positive and epsilon 1 is negative. Why it is epsilon negative? Because epsilon 1, epsilon 2 both are in the opposite direction. Epsilon 2 minus epsilon 1, and this always the resistance will be opposite. Minus IR1 minus IR minus IR2 is equal to 0. That's a loop rule. The algebraic sum of the potential difference is equal to 0. So epsilon 2 positive, epsilon 1 negative, opposite direction. The resistance will be always opposing the flow of current. Therefore minus IR1 V value minus IR minus of IR2. The current is same in the whole circuit, but the resistance are different, voltage is different. In the question, they ask us to find the value of R. Now rearrange the equation, change, interchange, multiply, add, subtract. You do whatever you want. Use your own mathematical skills and find the value of R. That's our idea. So R is equal to 6.6 into 10 power 2 ohms. And the second part, they ask calculate the value of power. The power dissipation, here the power will be dissipated in the form of thermal energy, which is equal to I square R. I is 1 times 10 power minus 3 the whole square. R is given, substituted, that's a value in terms of watt. The resistance in ohms and the power dissipation rate will be watt. That's the first question. And that's the second question. And the third one, the last question is 63. The current in a single loop circuit with one resistance R is 5 ampere. When an additional resistance of 2 ohm is inserted in series with R, the current drops to 3 ampere. What is R? So we have to consider the most important point is series value, series combination. So when two resistors or more than one resistor is connected in series, the equivalent resistance will be addition of all the resistors in that circuit. So here we have two resistors. One resistor value is resistance value is R, the other resistance value is 2. Now question is, what is R value? R and 2 are connected in series. Listen carefully. Current is given, and initially the current is 5 ampere. When they increase or when they add the new resistance, the current is dropped to 3 ampere. Why? More the resistance, less the current. Because when we increase the resistance, the flow of electrons will be stopped. Automatically the electrons will be slowing down. If the current flow will be less, 3 ampere. Now there are two parts. The first part, apply the Ohm's law. In every case, apply the Ohm's law. V is equal to IR. The first part, V is equal to IR. Voltage, we don't know. Don't worry about it. V is equal to I multiplied by R. Here, the first case, I value is 5 ampere and R values are the same. In the second case, V is equal to I multiplied by R plus R. You may wonder why it is R plus R. The R is the old one and the small r is a new one. New one is the 2 ohms. So now equate these two equations, that's our answer. Very simple. Let me go to the solution. You can look here very clearly. V is equal to IR and the I is substituted. V is equal to 5 multiplied by R. In the second case, V is equal to I multiplied by R plus R. R plus R. I is 3. R is the initial resistance. Small r is the new resistance 2. And this voltage we have already calculated, 5R. Now if you look the whole equation, there is only one unknown term, which is R. Use your mathematical multiply, rearrange the terms, you will get the value of R. 3 multiplied by R is 3R, 3 multiplied by 2 is 6. Therefore 5R is equal to 3R plus 6. Therefore R will be 3 ohms. So these are the simple questions we have to look into this. So we studied 3 questions. Let me go back one by one. The first one, we studied about the charging of a capacitor question. Charging of capacitor, Q is equal to C epsilon 1 minus e power minus t divided by tau. Here we calculate the value of t in terms of tau. In the second question, there's a most important part, single loop circuit. We apply the Kirchhoff's single loop rule. The algebraic sum of all the potential passing through the circuit is equal to 0. Here we consider all the electromotive force devices, EMF device, and the resistance and the current, which is equal to, we calculate the value of R, and then the power dissipation. Here the power dissipation will be in the form of thermal energy, P is equal to I square R. Finally, we use again the series method, series connection. The resistors connected in series. Series will be the equivalent resistance will be sum of the different resistances. So we add it together, we calculate the unknown resistance. So please study well and read the books very well. Regularly read the book and then prepare the topic. That will be helpful for you. Good luck. Take care.